Here we are taking about the electromagnetic waves. We are starting with the displacement current. Maxwell was the first one who mentioned about the displacement current. In any circuit where capacitor is there, the current is entering and current is leaving, but in gap there is no current. So he has found out that here there is displacement current and this one is the conduction current. So displacement current is produced in space due to change in electric flux. Electric flux already we have done. It is the number of lines passing through any given area linked with the surface. It confirms that varying electric field is the source of magnetic field. It means this thing, जो करंट यहाँ पर हमारे पास आ रहा है कंडक्शन करंट, ये चेंजिंग होगा, वेरिंग होगा विद रिस्पेक्ट टू टाइम. ओनली देन इट इज गोइंग टू प्रोड्यूस द मैग्नेटिक फील्ड. और उसने जो मैक्सवेल है उसने जो निकाला है करंट की वैल्यू, दैट इज इक्वल टू एप्सिलॉन टाइम्स change in the electric flux. Phi E is changing with respect to the time, and phi E is the electric flux, id is the displacement current. एक जो नई चीज उसने डिस्प्लेसमेंट करंट को इंट्रोड्यूस किया था, तो उससे हमारे पास जो लॉज थे इलेक्ट्रोस्टैटिस्टिक्स में और मैग्नेटोस्टैटिक्स में, प्लस हमारे पास जो इलेक्ट्रोमैग्नेटिक इंडक्शन में जो लॉज थे, उसने उन सबको क्लब अप किया. और जो एम्पियर्स का सर्किटल लॉ था उसमें मॉडिफिकेशन आई, क्योंकि उसमें सिर्फ हमारे पास कंडक्शन करंट नहीं, डिस्प्लेसमेंट करंट भी है. तो इन सबको जब हम लोग इकट्ठा कर रहे हैं तो मैक्सवेल ने उसके लिए इसको मैक्सवेल इक्वेशन ऑफ इलेक्ट्रोमैग्नेटिक वेव्स मेंशन करते हैं. गॉसेस लॉ इन इलेक्ट्रोस्टैटिक्स इज गिवन बाय closed integral of the dot product of electric field and the area, and it is equal to 1 upon epsilon naught times the charge enclosed by that area. Gauss's law in magnetism is B dot ds. This is again the total integral of dot product of magnetic field and the area, that is equal to 0. Why it is 0? Because the number of lines that are entering that area is equal to the number of lines that are leaving it. Faraday's law of electromagnetic induction, according to it, the line integral of the electric field enclosed one is given by the negative of the rate of change of magnetic flux phi b. And the modified Ampere circuital law, earlier it was B dot dl, the closed integral is equal to mu naught I. Now this I is replaced by IC plus ID. IC is the conduction current and ID is the displacement current. This is how Maxwell summed up all the equations, and these are the 4 important Maxwell's equation. Next point is about the electromagnetic waves. These are produced due to the change in electric field as well as magnetic field sinusoidally. Sinusoidally means following the function of sine, and y equal to a sine omega t. So that type of function of the waveform it is following, and propagating through space such that two fields are perpendicular to each other and perpendicular to the direction of wave propagation. It means we are having 3 directions x, y and z, they all are mutually perpendicular to one another. So if one of the wave electric field is along x axis, the magnetic field will be along the y axis, that is perpendicular to that, and the waves, that is wave propagation, will be perpendicular to both of that. So if in case I am taking x direction for the propagation of the electric field, that is changing with time, y for the magnetic field, that is changing with time, they two are perpendicular to one another, then wave propagation will be along z axis, that is perpendicular to both of them. The different types of electromagnetic waves, we are talking about the waves type, wavelength range, production, properties and uses. Among that, first we have talked about the gamma rays. Gamma rays are having the wavelength range 10 power minus 14 to 10 power minus 10 meter. You can find out the frequency. I have not made the table for the frequency. So to find out the frequency, you can use the formula lambda is equal to velocity of light upon frequency, or frequency is equal to velocity of light upon wavelength. So knowing the value of wavelength, frequency can be found out. Gamma rays are produced by the transition of atomic nuclei. The transitions that are inside an atom, that is the interior most part nuclei, when the transitions will take place there, then the gamma rays will be produced. or decay of elementary particles. This is a natural one. All elements won't be decaying the gamma rays. There are certain elements that will be during decay emitting out the gamma radiations. These are properties. Because the wavelength is small, frequency is very high, it is highly penetrating. It shows the phenomena of ionization, diffraction, it is chargeless, and because they are highly penetrating, they are very harmful to the human body. The uses: they provide information about the structure of atomic nuclei. Atomic nuclei is lying in the interior part of an atom, and to find out the anything about information about that, so we will be requiring a very highly penetrating rays that will reach inside the nucleus. So gamma rays are suitable for that. The next is the X-rays. X-rays are having the wavelength range 10 power minus 11 to 10 power minus 8 meter. Generally we used to say it is having a wavelength of 1 angstrom, that is 10 power minus 10 meter. So that is lying between that only. It is produced by the sudden deacceleration of high speed electrons. High speed electrons, they get encountered by some things present, some atoms present in the path of that. They will suddenly get deaccelerated and they release their energy in the form of X-rays, or the electronic transitions among the innermost orbits of atoms. The outermost atoms, the outermost electrons of the atom during transition will emit the rays that is having energy quite less. But if we are talking about the innermost electrons of the atoms, there the interaction, there is the transition, then in that case the X-rays will be produced. They are having all the properties that are of gamma radiations. They are penetrating, ionization, diffraction. They are also chargeless. They are harmful to human body, but not as much as the gamma rays are. Its all properties are same as that of the gamma rays, but they are less penetrating, and that is why X-rays are suitable for taking the information about human body also, because their ionization power is less as compared to the gamma rays. So the uses are: it reveals the structure of inner atomic electron shells. Now we are talking about the electron shells, we are not talking about the nuclei, because only gamma rays, they are having highly penetrating power more than the X-rays. That is why they will be reaching to the atomic nuclei. X-rays will be reaching to the atomic electron shells, inner one, and it help in the medical diagnosis, that is to find out the atoms, the innermost picture of a human body. So they will be using the X-rays. Ultraviolet radiations, the wavelength lies between 10 power minus 8 meter to 4 into 10 power minus 7 meter. They are produced by the sun radiations, or by the hot arc, or by the vacuum spark, or ionized gases. They produce the ultraviolet radiations. It is possessing all the properties of gamma rays, but its effect is less because it is less penetrating in comparison to the gamma rays. Produce photoelectric effect, it is absorbed by the ozone layer. These are harmful for human bodies, and in the atmosphere there is a layer ozone, and that absorbs the ultraviolet radiations coming from the sun to the earth. It is harmful to the human body. It is used to detect the invisible writing, fog documents, and the fingerprints. So in forensic it is having a very important role. It is also used to preserve the food stuff. The next is the visible light. Visible light, the wavelength lies from 4 into 10 power minus 7 to 8 into 10 power minus 7 meter. This is the visible range. It is radiated by the excited atoms of gases, or it is produced by the incandescent bodies. Its properties are: they show reflection, refraction, polarization, interference, diffraction, photoelectric effect. The uses: it is very useful for the photosynthesis or for the life. It reveals about the external shell of the atoms, because they are less penetrating, low energy, so they can't reach inside the atom. So outer shell of atoms can be revealed with the help of the visible rays. In the infrared radiations, The wavelength range is from 8 into 10 power minus 7 meter to 5 into 10 power minus 3 meter. The infrared radiations are necessarily radiated by the hot bodies or by the rotation and vibration of transitions in the molecules. The property is the most important one is it produces the heating effect. It reveals the reflection, refraction, diffraction, and this is again one of the important property, penetration through the fog. Its uses are in greenhouse to keep the plants warm, because it is penetrating through the fog. So the lamps are of infrared radiations are used to look through the haze, fog, or mist. The next is the microwaves. Microwaves are also called as the short radio waves, and the wavelength ranges from 10 power minus 3 to 3 into 10 power minus 1 meter. These are produced by oscillating the currents in the special vacuum tubes known as klystrons. The name of the tubes are klystrons. By electromagnetic oscillators in electric circuits. It shows the property of reflection and polarization. The microwaves are used in radar, radio detection, and ranging. The radio waves basically are used there. It is also used in the long distance communication through the satellites, and in microwave ovens that used for cooking, we use the microwaves or the short radio waves. And next are the radio waves. The wavelength ranges from 10 power minus 1 to 10 power minus 4 meter. They are produced by oscillating the electric circuits. The properties they possess are they show reflection phenomena, diffraction phenomena, and as the word it is indicating, the radio and TV communication system utilizes the radio waves. The next is the electromagnetic spectrum. It is the systematic sequential distribution of electromagnetic waves in ascending or the descending order of frequency or wavelength. We are having the in the spectrum the electromagnetic waves, 7 in number. The first is the gamma rays, then X-rays, ultraviolet rays, visible light, infrared, microwave, and the radio waves. If we go from gamma rays towards the radio waves, there is decrease in frequency. Highest frequency is of gamma rays. As we move from gamma rays to X-ray, ultraviolet, and so on, there is decrease in the frequency. Since frequency and wavelength, they are in reciprocal to one another. So when there is decrease in frequency from gamma rays to radio waves, there will be increase in the wavelength. Gamma rays in this spectrum is having the lowest wavelength, then it keep on increasing as we move from X-rays to ultraviolet rays. The next is the speed of electromagnetic waves in the vacuum. It is denoted by C, and it is the ratio of electric field in the vacuum to the magnetic field, and putting the values we get 1 upon under root mu naught epsilon naught. Putting these values, we will get the velocity of light equal to 3 into 10 power 8 meter per second. The energy associated with the electromagnetic waves is denoted by U, and it is equal to half epsilon naught E square plus B square divided by 2 mu naught. Since the electromagnetic radiations is consisting a part of varying electric charges and the varying magnetic field, so that is why it is both the things are contributing. Average electric energy, a part of that, and average magnetic energy. So both are contributing for the total energy of the electromagnetic waves. The linear momentum P is given by U by C, where U is the total energy transmitted by electromagnetic waves and C is the velocity of light. Another important thing is that electromagnetic waves, they do not require any medium for the propagation. So this is about the electromagnetic waves.